The universe was supposed to end quietly. Not with fire, not with collapse. Just silence, expansion, darkness. Stars burning out one by one until nothing remained but cold, drifting black holes. Slowly dissolving into nothing over a timescale so vast, the number has more zeros than atoms in existence. That was the plan. That was the settled science. It was wrong. In 1998, two independent research teams studying distant stellar explosions made a discovery that rewrote the future. The universe wasn't just expanding, it was accelerating. Something invisible, something with no identified source, no agreed-upon mechanism, was pushing space itself apart at an increasing rate. They named it dark energy, and they assigned it a value, lambda, a fixed cosmological constant, a number that never changes. Every calculation about how the universe dies, every simulation, every textbook, every peer-reviewed model written in the last 27 years was built on that number staying fixed. From that constant came the Big Freeze, the dominant model of cosmic death. Galaxies drift so far apart they permanently vanish from each other's observational horizon. Star formation decelerates, then stops entirely. The last red dwarf burns out after roughly 100 trillion years. Then black holes, immense, silent, solitary, reign over a universe of total darkness for spans of time that make 1 trillion years feel like a breath. And even they eventually dissolve, particle by particle, through Hawking radiation, leaving behind a universe at maximum entropy, maximum cold, zero structure, zero complexity. That was supposed to be it. But then, DEZ-ee arrived. The Dark Energy Spectroscopic Instrument, mounted at Kitt Peak Observatory in Arizona, is not a conventional telescope. It houses 5,000 individual robotic fiber optic positioners. In a single exposure, each one locks independently onto a separate galaxy or quasar. Each one captures that object's light spectrum simultaneously. In a single night, DEZ-ee collects more spectral data than the entire combined history of spectroscopy before it existed. More than 900 researchers across dozens of institutions pooled that data. They measured light from nearly 15 million galaxies and quasars, light that in some cases left its source billions of years before Earth's crust had solidified. They weren't building a map of space. They were building a map of time, of how dark energy has behaved across the full arc of cosmic history, from the early universe to the present. The data was released through 2025 and formally confirmed by April 2026. It did not match the model. Here is what the data shows. Dark energy is not a constant. It is a variable, and it is trending in one direction, down. The pressure that has been accelerating the universe's expansion for billions of years is measurably, demonstrably weakening. One of the study's lead authors did not soften that finding. They called it, directly, the most significant shift in cosmology since the discovery of dark energy in 1998. Sit with what that means. The scientists who spent their careers constructing the framework built on the 1998 discovery are the same scientists now saying that framework is fracturing. Strip away the language and follow the physics. Right now, every galaxy beyond our local group is receding from us, and it is accelerating. Dark energy provides the pressure driving that acceleration. If dark energy weakens, that acceleration slows. If it weakens enough, acceleration stops entirely. And if the trend the DEZ data shows continues past zero, it does not just stop, it reverses. This is the Big Crunch. A scenario that was, until very recently, considered cosmologically eliminated, crossed off. As recently as 2 years ago, before DEZ-ee's confirmation, most working physicists would have dismissed it without serious discussion. The Big Crunch requires a universe that eventually stops expanding and begins contracting. But with lambda fixed, positive, and stable, contraction was mathematically impossible. Except, lambda isn't fixed. The Big Freeze was a death by isolation. Every structure in the universe slowly separated from every other structure until nothing could meaningfully interact with anything else. No heat transfer, no chemistry, no physics of consequence, just distance, compounding across eternity. The Big Crunch is the physical opposite of that at every scale. Matter that has been spreading outward for 13.8 billion years begins to fall back. Not because anything physically pulls it, but because the space it was riding outward begins to contract. The cosmic web tightens. Superclusters begin colliding, then galaxy clusters, then individual galaxies, then stars, then as density spikes beyond anything current equations are built to handle, atomic nuclei can no longer maintain structure. Protons and neutrons dissolve. Matter itself breaks down into a plasma of pure energy as temperatures climb past anything in the observable universe's history. And then, nothing. Or something. We don't know. Some theoretical models propose the Big Crunch is not terminal, that the extreme compression generates a big bounce, a new expansion event, a successor universe built from the compressed wreckage of ours, carrying no information forward, knowing nothing of what came before it. But that is speculation stacked on uncertainty, stacked on incomplete data. What is not speculation? What 900 researchers confirmed using 15 million data points spanning billions of years of cosmic history is that the force governing this universe's fate is changing, and the direction it is changing eliminates the ending we had planned. Here is what stays with you after you absorb all of this. Every generation of humans that has ever lived assumed the universe would outlast them by a margin so vast it functioned as infinity. The stars would burn for trillions of years. The cosmos would expand forever. And somewhere inside that enormity, the concept of an ending felt abstract, theoretical, safe. DEZ-ee changed that. Not by shortening the timeline in any way that touches a human life. We are still discussing billions of years, but by revealing that the equation governing everything has a variable nobody confirmed was variable. The universe's death is not a fixed point in the future. It is being actively written, right now, in real time. In the spectra of 15 million galaxies cataloged by 5,000 robotic eyes in an Arizona desert. And the latest draft does not end quietly. If this kind of cold, unblinking truth is what you came here for, subscribe and keep decoding the dark reality of the universe via IAS.